Okay, welcome. You just missed the spiel about why we're doing all of this, where the formulas have come from the slope, but today we're focusing on can we use this formula nicely. Now, it is repeating some of the stuff that we did in our last unit, okay? Function notation. So, to keep your life easy, you're writing your function here. We know that this f dashed of x is part of the formula. It means derivative. Away we go. You copy the limit. Elliot, sorry, I just looked up and you were looking intently. Good chap. What does f of x plus h, what is that telling us to do? It's telling us something. Right, well, that's okay. Yep. It is not the function of x plus the function of h. Right, it is saying go sub. Go sub. Go to your f function, which is this, and wherever x is, please replace it with x plus h. Okay? So go to our f function. So I'm going to put the 4 there, and instead of x squared, it's going to become x plus h squared. Are we happy with that? It says minus, I put minus. It says minus f of x. What is f of x? 4x squared. I would argue we haven't really done anything mathematical at the moment. Well, a little bit of sub, but really we're just copying. What does the limit mean? So what we're doing, and this, I guess I should have done it before, but this is, I did, but we're repeating. This is explaining our slope or our formula, because downstairs here when we went x1 take x2, this is my x1, so x plus h take x. What does that give me? H, which is where this has come from, right? And your y values up here, well, when x is x plus h, if this is f of x, wouldn't my y value be f of x plus h? And my other y value would be f of x. So that's why we've got y f of x plus h minus f of x. It's y2 or y1 take y2, correct? You're saying, but why are we writing this limit as h tends to 0? We're trying to make this gap 0, right? We want to be at that point, okay? So what we're trying to do, and we want to do it as soon as we possibly can, is we want to make h actually 0, right? We don't want it to be approaching, we want it to actually be 0. But I cannot do it now. Why can't I do it now? Because we cannot divide by 0. Okay? So the aim of the game, formula, sub. Play with the top line. And what should happen is you should be able to pull out a common factor of h on the top line. That's if you've done everything correctly. And once you've done that, you can cancel out that h, then replace h with 0, okay? So, to get to that point, you are practicing some basics. So I love this topic because it reminds you, how do we expand x plus h all squared? Sean, Master? Don't be sorry. All right, so remember, there's that middle term. So if you had forgotten, which some of us do because it's the end of the term, our brains are a little bit overworked, write it to the side, okay? X times x, we get the x squared, we get the plus xh, we get another hx, we get an h squared, and then we remember, oh yeah, when we've got a perfect square, it's that squared, x times h, double it, and h squared. Yeah? Hello? Oh, you were saying thumbs up, right. So I've expanded that minus 4x squared all over h. Give you a moment to copy that down while I write my limit. People whose first lesson this is, I reckon every lesson people have asked, do you have to write the limit? Yes. Okay, this is what I like to call checkpoint Charlie. So if you have done everything correctly thus far, you've expanded properly. In a minute, we're going to look at a question where, there might be some negatives come into play. it's at this point where you can probably give yourself a little bit of a checkpoint to go, yeah, I think it's looking all right. Because what did we want to do? Pull out a common factor of h. So which means anything that doesn't have an h should cancel, right? 4x squared minus 4x squared. They're Gornsky. Gone. Okay. So happy days. I can now confidently pull out my h, and I get what would be in my bracket if I pull out h as a common factor. 8x plus 4h. We can, someone just asked, wouldn't you do 4h as the common factor? Yes, but really, I just want to be cancelling out the h, so I'm just pulling that out. Okay, the h's cancel, and it is at this point where you can sigh a big part of relief and go, oh, thank goodness, I do not have to write limit as h tends to 0 anymore. Why? Because, huzzah, this is the point where we actually make h 0. So the 8x will stay. What's 4 times 0? So it's just 8x. So what does this mean? It means that anywhere along this line now, let's say we could take, and by the way, we know 4x squared looks like this. It's pretty skinny. Yep. So we would be saying that when x is 1, the slope at that point, the tangent at that point would be what? 8. Correct. So at this point here, f dashed of 1 would equal 8. What would it be when x is 2? 16. Now that you can see it makes sense up there. It is steeper. Wow. What about when it is over this side? -2. Now, wait. When we draw that line, it is decreasing. So we know the slope has to be negative. Well, when we put -2 in here, 8 times -2 is -16. Works. Yeah? Make sense? I'm going to try and stop saying huzzah, because apparently I say that a lot. We had actually already done these ones before. Now, people who weren't here, don't worry. You could go back and do them later if you really wanted to, but I think you'll get the gist of what we're doing today. So at the moment, what function did we just do? 4x squared. So we had 4x squared, and we came up with our derivative is 8x. We're going to do a couple more. We're going to add to this table, and you are going to see a pattern, hopefully. You already see it. As we said at the start of the lesson, there are 2 formulas that we use. One, where we have a point, right? And it doesn't really matter which order you do them in. So for those who miss lessons, well, we're starting with this where we have no point. Okay? This is the one. And this works for every single one, but you will see if you actually have a point, it's easier to use the other formula because you don't have so many unknowns. But always double check. Little tip, you write your question, you write the formula. You are less likely to make a mistake substituting when it's right there. Okay? Here we go. Limit. Can I go? Is everyone okay? I mean, ideally, you'd be staying a step ahead of me. So let's suss this first bit. F of x plus h. Remember, what is it telling us, Els? We've got 3 to choose from. Huh? I want to sub x plus h wherever x is up here. Okay? So it's going to be 5. Instead of x squared, it's going to be, oh dear, x plus h squared. But you know, we've sort of done that now. We know how to expand that quickly. Minus 2, not x. What do we have to replace it with? X plus h. I'm coming. Now, minus f of x. So, minus. Now, I'm going to go brackets because not much sleep last night, might be making an error, so I'm going to avoid any errors. So, minus 5x squared, take 2x. And sorry if I forgot to tell people, don't draw margin. They become a long question. But how much has this hurt your head? You're just copying and substituting, correct? If you try and go too quick, you're going to make a stuff up. And this is not the spot that you want to do it. So slow and steady wins the race. It looks then like you're doing a massive amount of work. Right? Show it to your parents, as long as they don't know what this is all about. They'll be very, very impressed. Okay. Do we remember x plus h all squared? Yeah, what is it? Yep. One of the joys of repetition of maths. Minus 2x minus 2h. Oopsies. H. Thank you. Minus 5x squared. Minus and a minus make a plus. You are going to expand and carry on, but can I just say, what do you think is one of the most common problems or errors that students make? Subbing in 0 to, but it's this bit here. So if you didn't have the brackets there, right, you would have had minus 2x, and it's at this point where you check, because what are we hoping happens? That we can pull out h as a common factor, and so anything that doesn't have an h should disappear. So if you hadn't had your brackets and you had that, you would have had 2x minus 2x, which makes minus 4x. And so, it's got no h and it's still there. So that's when you should go back. Don't keep going. Go back and go, let me see if I can find an error somewhere. So what are you hoping that you will see on the left-hand side here? A plus 5x squared, yeah? Yeah. Anyway, let's see. Yes, we should be rejoicing because 5x squared, minus 5x squared. Love it. Minus 2x plus 2x. Woohoo! As opposed to huzzah. Right, we are pulling out h now as a common factor. So I get 10x. And by the way, Charlotte, for those who saw me just put the h back in here, I had actually not put the h in there, right? I would have realized that I had made a whoopsie because I would have had 10x and no h around. So I then go back and double check and go, oh yeah, doofus, I forgot the h there. Okay? Plus 5h, take 2. All over h. Oh, let's not write that. Therefore, f dashed of x, let's make h 0, so we're left with 10x take 2. Agreed? Yeah. So we're just adding that to our list of. Can anyone see a bit of a pattern at all? Got heads nodding. Pardon me? What are you noticing? You bring the exponent down. So 2 times 2, and then you minus the exponent, because that's technically a 1 there. 2 times 4 is 8. Take 1. Yeah, okay. 2 5s are 10. What's going on here, though? Right, 1 times 2 is 2, and what's 1 take 1? 0, and what's anything to the power of 0? Not 0. 1. Hamada. Hi. So before we went and did C, we thought we'd just do an x cubed first because I want to remind you of a few things. So we write it. We as a class looked at the pattern and we've made a prediction of what we think it should be. And now here we go. I'm going to be your scribe. Tell me what to write, please. Limit, yep. Yep. Yes, good. So x plus h to the power of 3, because this is saying go to your f function. Wherever x is, replace it with x plus h. Minus x cubed, love it, all over. Now, this is where I might scare some of you. Hopefully I'm not. To expand x plus h cubed, bit of a pain in the butt. I do not want to go x plus h times x plus h times x plus h. Some of you might argue, well, I could just do x squared plus 2xh times x plus h and then expand through by x, expand through by h. By all means you can. What I'm hoping is you remember this. Old mate. And say it with passion and pride. Pascal! 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 In a nutshell, if I was to expand x plus y squared, I get x squared plus 2xy plus y squared. Now, you're going to have to just trust me on this and not have to have me prove it out bit by bit by bit. If I was to expand x plus y cubed, I would get x cubed plus 3x squared y plus 3x y squared plus y cubed. I hope you're looking for patterns. Sorry for the boys and people at the back. You might have to stand up to have a look. But to now expand x plus y to the 4, that would be x to the 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed y to the 4. It's like so good. Anyone seeing the pattern? Remember, there are 2 patterns. What's the first one? The exponents, right, are the same here. So when I've got x squared, it is a 1, a 2, and a 1. When it's cubed, it's a 1, it's a 3, it's a 3, it's a 1. When it's to the power of 4, I've got a 4, I've got a 4, I've got the 6, I've got the 4, I've got the 1. What's the other pattern that you can see? What about the exponents? Right, they descend in. So this one, we start with x, it goes 3, 2, 1, 0. And anything to the power of 0 is 1. Over here, we've got 4, 3, 2, 1, and again 0. I could do the to the power of 5 if you really wanted me to. What's happening with the y's? They're increasing. 0, 1, 2, 3, 0, 1, 2, 3, 4. And what do all the powers always add up to? About 4. 4, 4. 3 plus 1, 4. 2 plus 2. 1 plus 3, 4, and so on. So it's a really handy thing to have in your back pocket. Seen it before? Knew you've seen it before. Seen it before? Understand it though? Appreciate it? Love it. Okay, so that means it can save us some time, correct? But of course, if you want to go here and do this to the side, by all means, go for it. Luce, you love it? Okay, I don't even need the bracket there. So this is going to be x cubed plus 3 x squared h, and I'll just be quiet in a minute so you can write down whatever it is that you need to remember this. So, bang, what you predicted was correct. So hopefully what you are seeing is you are getting a pattern. Like if I had x to the n, what would my derivative be? We bring the n downstairs, right? So it becomes n, x, and then what do we do to the power? N take 1. Ags was just about to say, Miss, how come we do all of this thing when we've got the shortcut? It's so we appreciate the shortcut. We can prove the shortcut. We're about to do a whole lot of stuff with the derivative. We're going to find the equation of the tangent using the slope. We're going to find it, the max min. We're going to find motion, velocity, acceleration. But we will never do it using all of this. But I can guarantee you now there will be one question in your test, at least one, where you have to do this with no point. There will be no x coordinate given. I shouldn't say no point. And there will be one question where you are having to do it long way, prove it, where you are given an x value, right? And that will be maybe 10% of the test. 90% we use the shortcut. Yeah? Okay? And if you notice up on my poster, the second one, it's been there the whole time.